Hi everybody, I hope you guys had a good weekend. Here's your video for 2.1.3, which is all about triangle inequality. So this section is called Is the Answer Reasonable? So if you are looking at the side here, at the online book, we only have this section and one more section. So just be aware that your guys' team test is going to be probably on Wednesday or Thursday, depending on how the lessons go. I'm hoping for Wednesday. So we are going to go through this lesson today. I'm going to do 2-99 in this video, so make sure you guys have your notebook ready for that so you guys can write it down. Then when you guys come to class, you're going to do 200, 201. 101 is our really big idea, so this is super important that you guys take time on it and you guys go through it and you guys are doing it correctly. And then 2-102 is the last problem we're going to get to, and then you guys will have an exit ticket like always. So, the first thing that I have for you guys today is a little joke. So I'll let you read that for a little bit. And we're going to go over this. So maybe we'll come back to this joke once we go over the methods and meaning part. But that side of the triangle is called the hypotenuse, and they replaced it with hippopotamus. So we'll come back to this at the end of the video, and hopefully it makes more sense to you. Alrighty. So if you don't have your notebooks out right now, go ahead and pause the video, get your notebook out so you guys can write 2-19 down, because it is a very important idea, but I think it's something that we can just go through in this video. So it starts with Rory. Loves right triangles, and he provided the one below to analyze. He wants your team to find the length of the hypotenuse, the longest side, so AC. So there we are using our vocab again, that we want to find what the side length of AC is equal to. Okay, so for starters, we're just going to estimate the length of AC. So estimate is just a rough guess. So in order for me to make a rough guess, I know it's the longest side, so I want to figure out what the other two sides are, so I know that it has to be longer than that. So I know side AB is 2 units, and I know that CB is 1, 2, 3, 4, 5, 6, 7 units. So it's got to be more than 2 and 7 units. So I'm going to say 8 or 9. So 8 or 9 units. Just a rough guess. Whenever it tells you to estimate in the book, just make sure you guys are making smart decisions on how you guys are estimating. Alrighty, Rory decided to repeatedly rotate the triangle on graph paper as shown below. So again, we're going back to our rotating, so that's why it was so important in chapter 1. He says the quadrilateral constructed on AC is a square. Do you agree? Justify your answer. So based on that, it looks like a square. So what we would need to do is talk about the side lengths. So this goes back to our definition about rotating. So if you are rotating something, does the figure change? Hopefully you all said no. So if we're rotating something, the figure does not change. So if the figure is not changing, that means all of these side lengths right here in this square are all equal. So if all the side lengths are equal, we know that that's the definition of a square. So going back to our definitions of rotating, pulling that from chapter 1 and using that to answer our question for this guy. So for that, you would say that all the side lengths are the same because it's a rotation. So some kind of transformation. Nothing is changing. Alrighty. So with your team, find a strategy to determine the area of the central square. Then use the area of the central square to find the length of the hypotenuse. Was your result for the hypotenuse close to your estimate? Why or why not? Okay. So what my thinking was for this is I am going to find the area of the biggest square here. And subtract that from the triangles. Or take the triangles and subtract it from that. Alrighty? So that's kind of my game plan. And you guys can if you come up with different ideas, let me know, because that'd be awesome. So what I'm thinking is I'm going to go through and I'm actually going to label this. So we know our longest side is 7 and our shortest side is 2. So I'm actually going to redraw this over here. Oops, not that. Rough sketch. Like I said, rough sketch. Alrighty. So we know that the shorter side is equal to 2 and the longest side is equal to 7. So I'm just going to go around the triangle and label all of my sides. So if this picture confuses you right here, go back to this, because I apologize, my drawing skills are quite horrible. Alrighty, so let's find the area of the bigger square. Alrighty, so this side's 9, 9, 9, 9. So to find the area, it's 9 times 9, so it's going to be 81. And now let's find one of the triangles. So remember, the area for a triangle is 1/2, base, which is 2, height, which is 7. So 2 times 1/2 is just 1, and then times 7 is 7. So what we are going to do is we are going to take 7 times 4, because there are 4 squares. So all 4 triangles, I'm sorry, triangles, not squares. All 4 triangles are going to equal 28. So 28 right here is the answer for all of these, the areas of all of those. And 81 is the area of the big guy. So all we have to do now is take 81 minus 28. I subtract weird, so I apologize. So roughly 53. So like we said, that is an estimate. So what we want to do is we want to find one of the lengths of those sides. So we want to find one of the lengths of those sides. And if you think about a square, it's always whatever the side length is squared. So if I draw a square down here, if the side length's 4 and the side length's 4, it's going to be 4 times 4. Another way we could represent that is 4 squared. So for the bigger triangle, if you go back up here for another example, it's going to be 9 times 9. Another way to represent that is 9 squared. So if you want to undo a square, you have to square root it. So for this answer, we are going to square root 53, and you get roughly 7.3. So it's the same idea. You're taking length times width, but your length and your width here are the same measure in a square. So that's why we can say we're squaring it. That's where that definition comes from. That's why it's 4 squared. Literally comes from it being a square. Okay, the area of a square. So in order to undo a square, again, we square root it. So we're going to take 53 and square root it, and you get 7.3. So that would be our length of our hypotenuse, or our longest side here. So if you zoom back in here, what we're saying right now is that this measure right here is 7.3. Alrighty. Okay. And then the last question says, will Rory's strategy of rotating the triangle and finding the areas always work to finding the longest length of a triangle? So will it always work? Well, what we just did always work. Yes, it will. The reason that it's working, as long as you are rotating it correctly and you do not do any mathematical errors, it will always work, because when you use a transformation, it's always going to be the same shape. So it doesn't matter what you're doing here. It's always going to be the same shape. So that is, and I know that there's a lot of work here, but that was question 299. So the idea here is find the area of the big square, find the areas of the triangle, subtract them. And then if you want to find the hypotenuse, you take the square root of the area, because that'll give you the side lengths. Alrighty. So let's go back to our methods of meaning. So this is in your book for you, but I would jot this down just in case you don't remember it, and this will go on our vocab sheet that I will be giving to you probably Tuesday in class. So right triangle vocabulary. So we will be using the word hypotenuse for a very, very, very long time. You guys should be going into trig and into calculus and into pre-calc. You will use that word all throughout those classes in Algebra 2. So really make sure you know what the hypotenuse is. It is always the longest side of a right triangle. So it's always across from the right triangle. And that's the biggest thing that people get confused here. So it's always across from the 90-degree angle. So it's always the longest side length. Which is why, if you go back to our joke, that was so funny. So hypotenuse is the hypotenuse. Alrighty. So let's run through some preview problems really quickly here. I want to go over the finding the angle measure one here really quick. We had some problems with that on our homework quiz. So remember, the biggest question you should be asking yourself is, hopefully you all said, does it make sense? Okay, so based on, they only give us one angle measure. So for me, my brain automatically goes to vertical angles. I can say that this guy is equal to 74 degrees. After that, I go, supplementary angles. I know 74 or 180 minus 74 has to give me my angle, my other angle measure here. So right here, that's supplementary with 74. So I'm going to get 106 for that guy. And based on vertical angles, I can also say that this guy down here is 106. Alrighty. So we know that only two lines were labeled as parallel lines. So we cannot assume anything about this line and this line. So unfortunately, we cannot find any of these angle measures. Even though they might be very close, they might be very similar, we cannot find anything about them because they're not parallel. If you look at this, ignoring this parallel line up here, we would say that this would be a transversal, but we cannot say anything because they're not parallel. So you're actually not even going to be able to find any of those. Alrighty. So if you go up, this right here is a corresponding angle. So those guys are corresponding. You could actually do corresponding angles for all of those angle measures and make those a valid argument. Using different vocab, this guy over here has to be an alternate interior angle, which is also vertical with these angles, which is also a corresponding angle to that guy. So a lot of different vocab you could use, which is why I said nobody's test quiz should look the same, because if you're thinking about your homework quiz, everybody's going to use a different method. Everybody's going to see it a different way. Just like 74 here is alternate interior angles with this guy, but it is also same side interior with 106. If it's same side interior, that means they have to add up to be, hopefully you said 180. Sorry, that says 74 degrees. And then using vertical angles, supplementary angles, corresponding angles, you know that this is also equal to 74 degrees. So that is that problem. Then the last problem for today's video is 2-106, which states lines P and Q graphed in problem 2-105, which I have down here in this picture, form a triangle with the x-axis. So how can you describe this triangle? In other words, what is the most appropriate name for this triangle? How do you know? If you would have done 2-105, you would know that these lines are perpendicular because of their slope. So I am just going to do a dot here and a dot here and say that this slope, the slope of line P, is 2 over 1. And then the slope of line Q is a negative, and it is 1 over 2. So we would say for question 1 that this is a right triangle. There's nothing else you can assume about it. So next it says find the area of the right triangle. So I'm actually just going to outline this. So area, again, we should have this memorized by now, is 1/2 base times height. So we are going to have 1/2. Our base is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our height, remember, you always go from this vertex point up here down to the base. 1, 2, 3, 4. So 1/2 of 10 is 5. 5 times 4 equals 20. So that's going to be our area. And then for the last question, we need to know the perimeter. So we need to rough estimate this perimeter. We're not going to know exactly what the side lengths are yet. The only one that we do know for sure is that the base is 10. So we are just going to rough guess this one. Alrighty. So first off, we know that 10 is going to be our longest side based on what we've been practicing. 10 is our longest side. You guys will eventually learn the distance formula for between points and all that fun stuff, so I don't want to show that to you guys now. So we are just going to run through, and I'm going to say this is about 1, 2, 3, let's say 3.5. And we'll say this one is 1, 2, 3, 4, 5, 6.5. So if we do that math, we get roughly about 20. Alrighty, so that is all I have for you guys today. I don't want to keep you on here any longer because I know this video is a little longer than normal. So I hope that you guys have a great night, and please make sure that you watch this video because it is super important for today's and tomorrow's lesson. So if you were confused about anything, please ask questions. Other than that, I will see you guys tomorrow in class, and have a great night.